Yeah, I'd just like to introduce myself. So my name is Simon Rowe. So I'm head of engineering here at Global. I work in a department called commercial trading, and we're essentially building all the sort of apps and services that bring revenue into Global. So I guess tonight's theme was actually sort of running Java services on Kubernetes. So maybe just start off with a quick sort of show of hands. Is anyone actually running Java services on Kubernetes? I guess some people probably are. Excellent. So yeah, I was going to drill in on a very sort of simple but sort of powerful sort of topic tonight around sort of automating dynamic configuration management with Spring Cloud Kubernetes. Because we've got a little bit more time, I'll probably dive into a few other sort of topics as well as we go, because there's plenty of topics in the small demo that I've curated as well. So yeah, might as well just get started. So yeah, I've got I guess a fairly sort of brief slide deck to run through, and these are the things I'm going to go through. So we'll initially sort of talk about what is a 15-factor app. So I don't know if anyone's heard of the 12-factor app, but I guess it's just a series of sort of principles for sort of running sort of cloud-native services or service on the cloud that are able to scale. We'll talk a little bit about what we use config for here in in a small set of services that we have at Global. I'd also like to talk a bit about the main sort of topic here and the very powerful library that is sort of Spring Cloud Kubernetes and why we use it. And then we've basically got a small demo, but we may sort of expand because we've got a little bit more time to run through that. So a working demo of Kubernetes running locally, an application where we've got Spring Cloud Kubernetes config, and we can show you how you can dynamically update your configuration without having to like redeploy or restart your applications. I've done a dry run of the demo already, which was a bit of a failure, but I've done the old sort of IT trick of turning my machine off and now back on, and it seems to be in good working state. And I'll talk a bit about how we actually deploy our config, because we actually have sort of CI/CD pipelines that will deploy the config to all the environments, without having to do sort of restarts and redeployments of our application. All right. So yeah, I mentioned there is a concept of a 15-factor app. It used to be a 12-factor app, but there's 3 extra factors added fairly recently. But like I said, it's a bunch of or a set of principles that describes a way of making software that allows companies to create code that can be released reliably, scaled, and maintained in a consistent and predictive manner. So I guess we've all, definitely sort of when I first started my career and, the cloud was very much in its infancy or didn't really exist, we'd always have sort of issues with sort of dev-prod parity where, we might be writing a feature that works in a dev environment and a QA environment, and the infrastructure for production was completely different. And when we actually deployed to production, something would actually fail. So the thing that we're going to sort of focus on within these 15 factors is the config. There's a couple of links there, and I think we'll distribute these slides later on. So config being one of these 15 factors, so I guess some really good principles are that we never really want to store configuration in our code, because when we actually have configuration in the code, if we want to change something, it kind of means that we have to redeploy our applications, restart. Time to market for those kind of changes can be quite long if we have to go through that, because occasionally companies might have compliance and we might need to raise change requests or something like that. So our config doesn't, a config varies across deployed, but code doesn't. So essentially, one of the other sort of factors is we want dev prod parity. So the code that we actually deploy is the same in each environment, and it's just a configuration that might slightly differ. We sort of prefer storing config in environment variables. and the environment variables can change easily without having to deploy any code. I'll probably put a little sort of caveat on that. So I guess in addition to using sort of environment variables to store our config, we can also use things like config maps, which I'll show with Spring Cloud Kubernetes in a minute. So the kind of things that we use config for, definitely we use config around sort of feature flags. So we've kind of sort of separated our actual code deploys from software releases. So as an organization, we're trying to sort of go down the mantra of sort of releasing code into production as quickly as possible. But we actually use feature flags to determine whether we actually will turn features on or off, right? So it allows us, because the more frequent we push code to production, the more we practice it, the less risk there is. I don't know if anyone's worked on software projects before where you might be developing features for 3 or 4 months, and then or even longer in potentially some sort of government organizations, for instance. Could be years that you're developing features, and then there's like a big bang release and it's just filled with risk and fear and long outages and things like that. So we try to sort of release software as frequently as possible, but sort of separate the actual enablement of features with feature flags. We also use config for some concurrency settings. And when I say that is I think it's probably something that's fair to say across lots of organizations. At some point in our careers, we're going to have to integrate with legacy systems. And such legacy systems, we might need to put things like rate limiting in place or certain things like that. I definitely know that we've had a couple of things with some of our third-party dependencies where we've put something live, and essentially we're essentially flooding downstream service with a lot of load, and actually just being able to sort of change those settings on the fly and sort of solve production issues in a really quick way through config is a really fantastic thing. Also with third-party integrations as well, some of the third-party APIs we use may have versioning, and when we've got might want to upgrade to the new version of their APIs, we don't necessarily want to do redeploys of our code, and it's easy for us to just change it within configuration. I mean, these are 3 pretty sort of small use cases that we use config for, and there's probably plenty of other sort of use cases that I haven't mentioned today. So I guess what is Spring Cloud Kubernetes? So it's essentially, Spring Cloud Kubernetes is a library provided by Spring, but the very small part of it that we're going to talk today about is it allows us sort of to externalize configuration using Kubernetes config maps and secrets. So it allows Spring Boot developers to store config externally in Kubernetes. And one of the very sort of powerful features with Spring Cloud Kubernetes is that we can actually apply changes to our config without having to restart or redeploy the application, which is a very, very powerful feature, especially if you want to respond to production incidents or you want to change configuration on the fly. So I've rattled through those slides in very sort of in a very quick fashion. So what I've got now is a demo where essentially I've got Kubernetes running locally on my laptop. So I'm actually using something called Kind, which stands for Kubernetes in Docker. It's just one various way you can run Kubernetes locally. I mean, you can also run it through Rancher Desktop or Docker Desktop or Minikube or what of. But just for the purpose of this demo, I've chosen to go with Kind. So yeah, I have a repo for this, so everyone can, once we all get home, people can sort of clone this repo or whatnot, and they can run all these examples locally. So everything is designed that you can play and experiment with this sort of example on your local machines. So how do we sort of embed Spring Cloud Kubernetes into our application? So there's a couple of like really simple things, because Spring Cloud, or definitely a lot of the Spring Boot starters are designed that they've got sort of, I guess, convention over configuration. So the idea is you can just drop the dependency in, and with minimal sort of configuration, you can become really productive really quickly. So there's a couple of dependencies that we need to add. So this example is using the Gradle build tool. So I'm not sure how many people here are familiar with Gradle, or show of hands. Yeah. Obviously, you can use this with Maven as well. But yeah, it's just a matter of adding a couple of dependencies to our build.gradle. Then we need to configure a couple of properties to actually say, okay, when we're actually running this demo on Kubernetes, we want you to pick up properties from this particular config map. And then we need to also add a @refresh scope annotation to our beans to tell it those beans to actually be refreshed when configuration actually changes in those config maps. There's a couple of extra things that are required as well. So, and I'll go through those once we sort of explore the code base. So I'll do a quick prayer to the demo gods, just to make sure this is all going to run smoothly. Right, so I'll switch over to IntelliJ now, and I'll just walk you through pretty quickly this demo application. Oh no, it's all right. As long as everyone can hear me, I don't think I need to use the mic. I think we're all good. Just shout if I sort of vary my voice too much. So like I said, all the code for this is in GitHub, so you can clone or fork this repo, have a look at it at your own leisure. But we've got a very simple, this is a very simple sort of Spring Boot application. So essentially, we actually have one sort of API in this app. So we've got an API called, just let me make this a bit bigger. It's just a get endpoint, which is /API/features, just to demonstrate that when we actually update some config, that the updates of that config is applied without having to restart. So yes, a couple of simple files. Got one controller. We've got the actual Spring Boot application just here. And we also have this file here, which is our sort of feature flags or configuration properties. So as you can see here, like I mentioned, definitely want to add the @refresh scope to this so that it gets sort of auto-updated once our configuration changes. Also using, we use a library called Lombok for some of our services as well. I don't know if anyone's familiar with Lombok. Yeah, it sounds like it's a fair few, so probably no need for me to drill into that in any more detail. Right, let's go to the build.gradle, which is our build file. So there's a couple of really interesting things within here. So there's two dependencies we absolutely need. So this Spring Cloud Starter Bootstrap, and also the Spring Cloud Starter Kubernetes Fabric 8 config. So there's pretty much all the dependencies you need to sort of plug into your application to get up and running with this. I did also mention that in our bootstrap.yaml, which is some of our bootstrap configuration, we essentially need to tell Spring Cloud Kubernetes where we want it to load some configuration from. So you can kind of see that I've got a few things set up here. So I've enabled sort of Spring Cloud Kubernetes reload. So it means that when you actually make changes to your configuration, it will get reloaded. And I've told it to load from a config map called feature flags. So if anyone's not familiar with a config map in Kubernetes, it's essentially just like a key value pair. I'll show you essentially what it looks like, because I've got an example one just here. So if we make that a little bit bigger. So this is a config map. The name of the config map is feature flags. And essentially, we just actually have one property here, which is called application.yaml. And it's a kind of a multi-line property. So you can see it's just YAML format. So I've got feature flags. And in this sort of sample application, I've actually got 5 features, and when we show this application for the first time, they'll all be turned off. But essentially what I'll do is I'll make some changes, reapply the config map, and then you'll automatically see that that they get updated on the fly. So I might as well just actually just demonstrate this to you, so you can actually see them working. Then we'll explain a couple of extra things as well. So let me just exit out of there. So I'll just hit refresh, and the good news is that it's actually working. So this is my endpoint running on Kubernetes running locally. So you'll notice this is not actually a real URL. So there's no such URL called springcloudk8sdemo.com. But what I've actually fudged is I've fudged my host file to make it think that, well, we can actually have a quick look at it actually. So if I clear that and I just do a quick cat of etset hosts, you can see I've just mapped this to localhost or 127.0.0.1. So this is actually all running on my computer. There's no smoke or mirrors just here. So what I want to do right now is I want to actually make a quick change to this config map. So we can actually just make them all. Let's make those true. Okay, so now we will have a config map that has feature 1 turned on, feature 2 turned on, and feature 5 turned on, and feature 3 and feature 4 are both switched off. So I do actually need to apply the changes to the config map, and all the instructions for this are actually in the README. So I'm going to quickly just find where it is, and I'm going to do a quick copy and paste. So my new config map has just been deployed. We can just have a quick look to make sure it has been deployed. So if I do kubectl get config map, it's called feature flags, wasn't it? Just pump that to YAML output. So you can see that the new version is now reflects what I've got in the IDE there. So another quick praise to the demo gods, because I'm going to go back into that web browser and refresh, and hopefully what we'll see now is we've got 3 properties set to true and 1 property essentially, or 2 properties set to false. So you can see I was actually able to make the changes to that config, apply the config to the environment, and the config just get automatically picked up without me having to do a restart, which is really quite powerful. You're probably asking, how does this actually work behind the scenes? Yeah, okay. So essentially, like, Kubernetes exposes various different APIs. So Kubernetes actually has an API which Spring Cloud Kubernetes is talking to. So there's one particular API it's actually sort of subscribing to. So there's actually a watch endpoint on config maps. So it's essentially like a WebSocket connection. So every time a config map changes, we've got a WebSocket client from Spring Cloud Kubernetes that will essentially subscribe to changes. It does mean that when you're running these services on Kubernetes, you need to make sure that we have the right permissions in place so that our services can actually access that config maps watch endpoint. So essentially for this, and this is something, I don't know how many people are familiar with Helm at all as well in terms of Kubernetes. So slight segue, but we most of our, or some of our services, we deploy via sort of installing and updating certain Helm charts. So we actually use a generic Helm chart for everything, and the generic Helm chart that we use is called Gruntworks K8 service. And most of our services are, it's very configurable. You can turn ingress off. It can be a headless service. You can set up things like horizontal pod auto scaling or whatnot. It's very configurable. But if we have a look at this very, very quickly, because I'm going to show you this right now, I should probably make this a little bit bigger so people can see. One of the things that we actually deploy as part of this Helm chart is some custom resources. So there's a couple of Kubernetes things or concepts that we need to set up here. So one of the first things we need to set up is we need to set up a role, essentially. So you can see this particular role allows config maps and secrets. So those are the actual Kubernetes APIs, and we allow sort of get, list, and watch on these because our service needs to be able to talk to the Kubernetes API and authenticate with it. And then we have essentially a role binding. So our service actually uses something called a service account, and then the service account essentially has a role binding which says which roles the particular service account can use. So you can kind of see here that we've bound the service account to that particular role, which will essentially then let us access these various APIs. If you were to try to do use this service account to access, for example, the pods API or one of the pods endpoints, you wouldn't be able to because it just wouldn't have the right permissions to. Yeah, I guess other notable things to sort of mention within this demo. So I mean, like this Gruntworks K8 service is the Helm chart that we use, and you can see that if I scroll down a little bit, you can see I'm actually using a. Yeah, it might be worthwhile if we just run through some of the CI/CD because some of it does mirror what we do at Global in certain places. So in this particular example, actually using like a CI/CD process called GitHub Actions. Now I don't know how familiar people are with GitHub Actions, but I've got a very, very simple, I guess, pipeline here that will run on sort of the main branch. And essentially, I'd probably just need to make this a little bit bigger. So let's do that. So this doesn't do an awful lot. I mean, essentially all it's really doing is, we're creating a tag in GitHub because every time we create a new release, we want to have a tag. So creating a tag in a GitHub release. Also, we're actually using the Spring Boot plugin to actually generate our image. So you can see here we're doing a Gradle build. Boot build image, and then we're publishing the image to GitHub container registry as well, and then we're also uploading some reports to GitHub Actions as well. Yeah, trying to think of what else we can go through. So I can show you that in GitHub because it's pretty straightforward here. So if I go to packages. Just trying to click on this package. Doesn't seem to be yeah, interesting. Okay. It's taking, I think GitHub is just taking a little while to load. So you can see like every time I commit this, obviously it's, well, I've probably not used, because this is just demo application, I probably haven't really used best development processes like committing directly to main and not raising pull requests, but because it's a small demo, I don't think that really matters, right? Yeah. So I might just quickly flick back to the actual slides, but like I said, like this is going to be available for everyone to, whether they want to clone it or fork it or whatnot, and there's a really good set of instructions in the README in terms of like how you can actually set up kind, which is Kubernetes in Docker, how you can apply the config map, how you can install the Helm chart and so forth. So it's all there for you to go through. I think I only really have one more slide left to go, plus some questions and some links. So let's kick that off. Back again. So you're probably also wondering, I I'm not going to bother with the microphone. I think everyone can still hear me. It's a bit of a faff to get up and walk all the way over there. But how do we actually deploy these config maps? Because you can kind of see I just did a really, really quick hack then. I just did a kubectl apply. But we essentially have, we actually have GitHub repos that contain the config. And it contains the config maps per environment, essentially. So, and this GitHub repo is treated like any of our other development repositories. So yeah, so we treat this like any of our sort of development repos. So if you want to make changes to configuration, it's going to require a pull request, and depending on how we configure it, we might have one to many approvers, and then these repositories also have pipelines that actually, once the pull request has been approved, we actually deploy these config maps to each environment that we have, so that they can be picked up on the fly. So basically, the reason why we have a config map is all changes are versioned. So I guess in the good old days where you might have someone from infrastructure potentially just remoting into the VM or physical server and just making changes on the fly that are not audited, or there's no history and no one really knows what's happening. I think the good thing about having the configuration in a GitHub repo is that you've got the full auditability. If you need to roll back, you can just go to the previous commit and revert changes and whatever you need to do. And also having the ability to have like pull request approvers means that changes to config can be reviewed, because I guess we all know with sort of software development, changes that can be one character can be really quite dangerous in certain circumstances if you make such a mistake. So it's always good to have any sort of changes, whether it's config or development, to be reviewed by a peer and approved before you actually push it out there. So yeah, mostly we actually have a combination in terms of our CI/CD, combination of GitHub Actions, and we also have Jenkins declarative pipelines as well, and we have a fairly sort of feature-rich library of Groovy functions and classes to help us. So our Jenkins files look fairly minimal because we rely on a really sort of solid library for that.